Every second, modern enterprises generate millions of machine events, logs, metrics, traces, security signals. Somewhere inside that data is the answer to what's breaking next. The problem isn't scale, the problem is speed.
When something goes wrong, we call it an incident. A security incident, an IT incident, a DevOps incident. But in reality, it's always a business incident. By the time humans have even received an alert, the impact has already begun. Data moves at machine speed. Decisions don't.
But what if the bottleneck wasn't people and it wasn't data? What if the bottleneck was the time it takes to understand? What if AI didn't just summarize dashboards, but actively investigated incidents?
With agentic AI leveraging Splunk, it takes minutes. This is secure, resilient AI infrastructure. Cisco AI pods provide enterprise-grade AI compute, purpose-built for secure inference and scale. They deliver isolated GPU resources, predictable performance, and policy-driven controls, so AI workloads run reliably, securely, and at scale. Splunk's Model Context Protocol acts as the intelligence layer, governing how AI queries logs, metrics, traces, and security data that have all been centralized within the Splunk platform. Splunk AI Assistant extends the capabilities of your native LLMs by enabling them to reason over machine data, generating, optimizing, and executing SPL, correlating signals across domains, and delivering actionable insights automatically. The result is agentic AI that doesn't guess. It asks the right questions, fueled by data housed in the Splunk platform.
Let's take a deeper look at how this technology works, starting on the left with the MCP client. This could be something like Claude Desktop, VS Code, or another AI-powered interface, essentially where a user or another AI agent asks a question. That MCP client doesn't talk directly to Splunk data. Instead, it connects to the Splunk MCP server, acting as a controlled, governed entry point for AI access. The MCP server translates those natural language questions into structured, policy-aware requests. Under the hood, it uses Splunk's REST APIs to interact with the Splunk platform, just like a trusted app or analyst would. This means access is governed by existing Splunk roles, permissions, and data controls. No shortcuts bypassing security.
Inside Splunk Cloud, the AI Assistant service runs as a fully managed Kubernetes-based service. This is responsible for reasoning, deciding what data to ask for, how to refine queries, and when to iterate. It doesn't just run one search and stop. It can think, adjust, and optimize SPL iteratively, just like an experienced engineer would. When language understanding or deeper analysis is needed, the request flows to the inference service, which interfaces with your large language models, hosted on Cisco AI pods. This is where reasoning happens, summarizing results, identifying patterns, and determining next steps. Crucially, the LLM never has unrestricted access to Splunk data. All access remains mediated by MCP and the Splunk AI Assistant. Once analysis is complete, insights flow back through the same controlled path in just seconds. Finally, the answer is returned to the MCP client as actionable insight, not raw noise. The key takeaway here is control. Cisco AI pods provide the secure compute foundation. Splunk MCP governs how AI interacts with data, and Splunk remains the system of record. This is how you get machine speed insight without sacrificing trust, security, or observability. Let's review that critical alert from earlier and see how Cisco and Splunk could have saved us time.
Instead of opening dashboards or writing SPL, I pull up the chatbot connected to my LLM to ask a question. Here, I can see all of the capabilities MCP and Splunk's AI assistant have enabled for my LLM to use. We've just gotten notice about an issue in our online boutique store. We're going to use our LLM's brain along with Splunk MCP to acquire information, correlate, and investigate what is happening. Behind the scenes, the AI agent is doing what a human team would do, but in seconds. It's pulling data directly from Splunk and Thousand Eyes, correlating infrastructure and network metrics, checking recent alerts and incidents, and scanning for anomalies.
My AI agent has just reviewed alerts across 4 different affected components that support my online store. The determination? For us to investigate a problem with DNS resolution in my AWS load balancer. Now I'm going to have it dig a bit deeper to help me understand the scope of impact and provide a list of affected hosts for my Meraki data. Let's break down exactly how it answers this question. The LLM leverages the Splunk MCP server to get a list of relevant index names for my Meraki and SD-WAN data in Splunk. Now that it's located the data, it uses the Splunk MCP server and AI assistant to get metadata and run SPL queries. The result is an executive summary which includes critical findings, timeline correlation, and the scope of all impacted cloud infrastructure and network devices. Within the root cause summary, my LLM has provided me the names of the exact teams to engage to fix this issue, reducing the need for lengthy war rooms and finger pointing. Impact identified, blast radius mapped, and rollback recommended. This isn't AI replacing engineers. This is AI removing the delay between signal and action. Let's take another look at that incident timeline from earlier.
Traditionally, this investigation takes 45 minutes, sometimes hours. Multiple teams, tribal knowledge, manual correlation. With secure, agentic AI on Splunk, it takes minutes. Mean time to understanding collapses, and the value scales across the business. IT resolves faster, SREs protect reliability, security investigates proactively, executives see impact, not noise. Splunk already knows the answers. MCP lets AI ask the right questions instantly.
This is what secure, resilient AI infrastructure looks like. Not dashboards faster, but decisions sooner. Not more alerts, but clear answers. Built on Cisco AI pods, powered by Splunk MCP. Machine data at machine speed.